Hi everyone, this is a reintroduction to Project 3. So let's start by overviewing the files, or the most important files. That I recommend you read all these in their entirety so that you can help get the big picture. So even reading the test programs can give you insight into how your syscalls should be set up. And take written notes. Writing things down has been proven to help make you cognitively process information. All right, here's a project description. We'll go over that momentarily. You can skip these two. Here are the code for the shared libraries. This is the kernel documentation on semaphore.ar on the semaphore facility. So that's how the semaphores are implemented. Looking at these files won't give you any insight into how to use the semaphores, but the project description shows examples. And then these are the four test programs. For C background, I like the GNU-C reference manual here. There are others that you can look through, but in the C reference manual here, going through the table of contents, there's material on structures and how to define and use them conceptually. Since you're coming from a Java background, a structure is quite similar to a Java class that has no methods, in which every field is public. Further along, there's information on using the size of operator and then the pointer operator's address of and dereferencing that you'll be making use of in the project. All right, so let's start with the project description at this point. Okay. So remember, with the Linux kernel we're using now, that you had previously pulled from GitHub and attached to your own repository, these are the make commands you'll use. All right, these are the instructions for compiling and installing the shared library. This if necessary part you should not have to do. You can double check to make sure that I did it correctly for you. But I don't think it's necessary to change any of the syscall numbers unless you change them yourselves for some reason, and there's no reason to do that. Okay, should just be able to follow the instructions there. As I noted earlier, read everything carefully. That's the letter L. That's the numeral 0. Okay. The first syscall you're implementing is current time. You're going to use the kernel function kTime_getReal to get the time. As it says, it returns the number of nanoseconds. What you're returning to the user via the syscall is a struct timespec, which has this structure. So you have to convert nanoseconds to seconds and nanoseconds. Conceptually, that's the same process as If you have 420 cents, what is that in dollars and cents? That's $4.20. That's what you're doing here. And keep in mind that a nanosecond is 1 billion 10 to the 9th seconds. Now, the structure declaration is here for purposes of illustration. It's defined in the include file time.h, which is already included in the lab syscalls source file. So you don't need to redefine struct time spec. If you did, you'd probably just get a warning. I think you just get a warning. I don't think the compiler will throw an error. So you're going to take the existing stub function in lab syscalls.c and replace what's there in the stub function for the parameters type to this. And then this pseudocode is pretty detailed. You're just going to convert this to C. These syscalls all return ints to indicate status. Negative values are used to indicate some sort of an error has occurred. 0 is used to indicate success. Keep in mind that you have to use the kernel function copy to user to copy your local struct time spec from kernel space back to user space at the address pointed to by RT. Copy to user takes 2 pointers, so you're going to use the address operator to get the address of the struct time spec that you declared locally. Okay, producer consumer. Let's start off by looking at the pseudocode in the textbook. All right, let's start with these global variables in the pseudocode. So a binary semaphore and 2 counting semaphores. Notice, where are they? This code is accomplishing the very same thing. So lock is the binary semaphore, full and empty are the counting semaphores. What we have here are 4 buffers. Message is an array of 4 char arrays, each of length 1024. So in your code, you will just be single indexing message. That will yield the address of the first character of the corresponding char array. And with copy to user and copy from user, it's that address of the first character of the char array that you need to pass. Can't remember whether or not Linux/semaphore.h may already be dropped into the lab syscalls.c. You may not need to copy that, but you can copy this code verbatim into lapsescalls.c to get started. Okay, and you're going to modify the declarations for the stub functions for labsyscall3 and labsyscall4 this way. Okay, right, so here's information on using access OK. Always, before you invoke copy from user or copy to user, use access OK. If you're using copy from user, you're reading from user space. So you need to, the type will be verify read. If you're using copy to user, you're writing to user space, you're going to use verify write. Right, and here's how to use copy from user and copy to user. Here are the examples of how to use the semaphores. So what does this correspond to over here? Okay, wait and signal over here. Down interruptible corresponds to wait. Up corresponds to signal. The big difference from here to here, as you can see, down interruptible has a return value that you have to check, as do copy from user and copy to user. Copy from user or copy to user returns anything. If it returns a positive value, then there was a problem, and you should assume failure. Similarly, if down interruptible returns anything other than 0, there's a problem. It says you have to clean up and get out. You simply can't return a -1 at that point because you may be holding resources. Okay, let's look at an example. Let's see. All right, here's a producer. And remember, as pointed out in the project description, you are not implementing the loop. Your produce syscall is only implementing the waits, the adding a string to the buffer, and the signals. Okay, so if the down interruptible to grab an empty buffer fails, think for a second. Is the process holding any resources? No, it's not. And so if that down interruptible fails, you can simply return a -1. Moving along, let's say the down interruptible to grab the mutex, which, what did we name that over here? Lock. Let's say that fails. Do any resources have to be returned before returning the -1? Think about that for a second. Yes. You have to do up on empty because you're holding an empty buffer. What happens with the wait on empty and the wait on full, you're either reserving an empty buffer or reserving one of the full buffers. Right, so that's an example of, as you go through this, if something fails, think about the resources you're holding, release them, and then return. Okay, so this needs to be done for the down interruptibles, copy from user, and copy to user. You can assume that the ups never fail. Okay, so again, you are not implementing the while loop, just the code within the loop for the producer. And here's the pseudocode for the consumer. And again, with the consumer, you're not implementing the while loop. Okay, where's... Okay. Do I have... All right. Here's the lab syscalls. That's all right. So there's the include for semaphore.h, so you don't have to re-include that. So these are the stub functions that you're going to replace with the correct parameters for each of your syscalls, and this is where you'll be adding the code. You should drop in the code, the global code for setting up the semaphores and the buffer right about here before the produce and the consume. And I can't remember offhand which of these is produce and which is consume. Remember, if I've pointed out previously, push early and often to GitHub. For an example, let's look at the commits that I had as I was getting this ready for you. Okay. And your commit comments should be informative. Keep in mind that you're writing these for someone else. It's not at all helpful if you write things like commit 1, commit 2, commit 3, commit 42. Write them so that someone going through your history of commits can understand what your work process has been. And so these are meaningful. That's meaningful. That's meaningful. Do the same thing with your commits. And don't wait till the end to do one huge push. When you're using Git, you're supposed to expose the messiness of the design process. That's expected. And that's what I'm expecting to see from your repositories. All right, see you soon.